I'm going to talk about properties of exponents today. Let's do a quick review. This is read as 4 to the third power. The 4 is the base, 3 is the exponent. Powers involves repeated multiplication. So we can express this as 4 times 4, which is 16, times 4. So 4 is multiplied 1, 2, 3 times is what the 3 means. And if you evaluate it, you would get 64. For everything that we're going to do today, you can kind of use logical reasoning to figure it out on your own. But you're going to have this understanding in order to do that. Product of powers involves when you have things with the same power. And we'll use the 4 again. 4 to the third multiplied by 4, let's say to the fifth. And what that would look like would be all this. 4 times 4 times 4. That would be this part of it. Then this part would be 4 multiplied 5 times. So you have a total, 4 being multiplied, a total of 1, 2, 3 times here. 1, 2, 3, 4, 5 times. A total of 8 times. And if you're thinking 3 plus 5 is 8, it's that easy. It is that easy. So we could say that 4 to the 10th multiplied by 4 to the 20th would be 4 to the 30th. Because you're going to have multiplied 10 times here and 20 times here for a total of 30 times. Now that's just using numbers. Here is the algebraic definition. If you have x to the m times x to the n, that equals x to the m plus n. So that's the rule for product of powers. So you're pretty much an expert on product of powers, quotient of powers. Remember that question is the answer to a division problem. So we did multiplication in the last slide. Today it's division here. And you kind of would probably, by logical reasoning, say, well, the rules are probably inverse of each other. And they are, actually. So what happens if you have 3 to the 7th divided by 3 to the 4th? You'd have 7 3's in the numerator, 4 3's in the denominator, and you can cross off for every one. This is a 1. 3 divided by 3 is 1. There's another 1, so they would disappear. Another 1. 3 divided by 3 is 1. Another 1. 3 divided by 3 is 1. So what you're left with is 3 to the third power, which is actually what you get when you do 7 minus 4. 7 minus 4 gives you 3 to the third power. So the algebraic definition of x to the m divided by x to the n is x to the m minus n. But take a look at this. When you have the 4 and the 7, the rule would tell you, you would do 3 to the 4 minus 7, which is 3 to the negative third power, which makes sense if you think about negative exponents and what we learned in a previous lesson. We could cross off 4 of these and 4 of these, and you have 1, the space here, 1 over 3 to the third. That's not a 33, that's a 3 to the third, which is the same as 3 to the negative third power. The language that's often used for this case is power of a power. It kind of makes more sense to me, at least, to call it a power to a power. It's talking about if you have something like 7 to the third power to the fourth power. So that's the power of a power. That's what we're talking about when that happens. This would take me a long time to write this one out, so let me make a smaller one. Just kind of get rid of that one. Let's say 2 to the third to the second power. So we can evaluate 2 to the third as being 2 times 2 times 2. And we're going to take that to the second power. So we're going to take it twice, which would be 2 times 2 times 2. That's 1 time. and 2 times 2 times 2 again, which is 2 to the 6th power. So what do you do with 3 and 2 to get 6? Right, multiply them. So here's your algebraic definition. X to the m to the nth power equals x to the m times n. Not m plus n, but m times n. So let's take probably can write this one out. 7 to the 3rd to the 4th. That would be 7 times 7 times 7. That's one time. 7 times 7 times 7. That's twice. 7 times 7 times 7. 3 times, but this tells us we have to do it 4 times. 7 times 7 times 7. So a total of multiplying 7, a total of 1, 2. Start counting over again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times, which we get by doing the 3 times 4. So it's 7 to the 12th power. In the last slide, we'll take a look at some examples. Our first one is 10 to the 3rd times 10 to the 5th. This is the product of powers, and that would tell us our rule is to add the 3 and the 5. So this would be 10 to the 3 plus 5, which is 8. Next problem is a quotient. So we want to think about what do we do? We're finding the quotient of powers, and it's the rule is subtract. So we're going to do 6 minus 3 to get the exponent. The base stays the same, so we're going to be 12. 12 to the 6 minus 3 give us 12 to the 3rd power. In the next example, there's a product here, and then this is a division bar. So there's two things going on. We'll simplify below the bar first. So it'll be 7 to the 9th divided by, and in this case we're going to do, it's a product of powers, so it's 2 plus 4, 7 to the 6th. And then subtract to get this. 9 minus 6 would give 3, so it would be 7 to the 3rd power. The last example is a power to a power, or power of a power. We would have this 9 to the 12th 10 times. 9 to the 12th times 9 to the 12th times 9 to the 12th. I'll stop there 10 times. It's going to be 9 to the 12 times 10, which would equal 9 to the 120th power. And, yep, that's it for today.